Oh, Jesus. 3. 3. 22. 24. Grace should be there. Jeremiah. Elliot. McKinney. Robert. Robots. Lee. Adams. And Stella. Campbell. Hello, can you hear me? Hello, can you hear me?
Yes.
How are you all doing?
Good evening, Professor. Good evening, class.
Hey, how are you today?
All is well. Can't
Oh.
complain.
You guys are excited because next week is the spring break, right?
That mean no work?
Yeah, yeah, no work on next week. It's true. The only thing you have is the classwork and the homework, and the homework I made it to be due after the spring break. So you should be good. And yeah, so next Friday, no class. You don't have no class this Friday. You just enjoy yourself. And then when we come back from the break, we go back to work, right? Okay.
You said you counseling class tonight and next week?
No, I didn't say that. Mr. Gamble, you heard what you want to hear, okay? I said next week, no class next week because of the spring break. And no assignment is due next week. So I'm making the assignment, this homework due after the spring break. So the only assignment due to is the one that is the classwork, that's all. Yeah. So let us continue to maintain good attendance. Remember, we have a deal, right? We had a deal. Second last week of April. If your attendance continue to be good, up to 70% at least, then you can request for makeup work. But the makeup work, unfortunately, the makeup work does not include tests. It can be homework, it can be classwork, but not test. Sorry about that. So test is the exam. Why are you doing your face like that, Mr. Gambo? You know this already.
But Professor, see, the thing is, the test has more weight than the classwork and the homework.
Says who? Let me show you something, Mr. Gambo.
Okay.
Just give me a minute. Let me show you something.
Because the classworks are worth 100 points. The classwork are worth 100 points. So like I got one.
I want to show him something. I'm going to the syllabus, right? So Mr. Gambo, I can't believe I spent hours making this syllabus ready. You never went through it. Hours I spent preparing this syllabus. Oh, look at this. Okay. Okay. Tests and exams. Okay. Okay. I see why she said that. But you see that the classwork have 20%, homework have 15%. If you add them together, that's 35% right there. See what I mean, Mr. Gambo? Can you see?
They started talking. All right, we got 20.
Yeah, it says 20%. Exam is 25%, yes, but the homework and classwork is together make up 35% of the grade.
All right, I'll take that.
So I'll take that. All right, Mr. Gambo, let me close this syllabus now. So I can show you guys what we have for the week. So, like I said a few minutes ago, the assignment we have are only classwork that is due tonight, which you can submit tomorrow. Then the homework 6. This is not the due date. I'm gonna change it. I will show you that I have changed it to after the spring break. Look, I will go to the models. If you scroll down to the models, you will see that I changed the due date for the homework to April 7th. You can see right here, right? Can you see it? April 7th. So the due date in announcement is not the correct. Let me adjust. I did the announcement. Due date is for the homework is not the correct one. That's the old due date. So I'm gonna make it. I've changed it already. So you just make it April 7th, not March. April 7th. So I changed it already. So it should be good. All right. So the classwork and then the homework. Now, let us begin. Today we are looking at the normal distribution. I remember there is this table I asked you to print and keep it handy. And I explained that we'll be using it from now on. Okay, 2 people entered, Thomas and Odoms. With Thomas, Amarike, and Odoms. Odoms, I think I have already. All right. There are 2 things I asked you to a table I asked you to print. I remember I mentioned that it is right here. Statistical table. I say print it. We'll be using it from now on. And we used it last time, and we'll be using it tonight as well. So I also placed it here again. Then there's another thing you need to print, which is this chart. We'll be using it tonight and henceforth. So these 2 things you need from now on. Print them and keep them handy. Let us begin. Our topic tonight is normal distribution. Now, many continuous variables like height, temperature, cholesterol levels have distribution that are bell-shaped. I mean, some of those distributions that we consider certain things to be normal. Mr. Elliot, are you good? Miss Elliot, you good? Huh? Okay. Yeah.
Yes, I'm good. I'm good.
Okay. So, like now, we have.
I didn't use that table last time though because I used Excel, so now I don't have it printed out.
Okay, good, excellent. So like now we know the normal blood pressure, right? Is the variable that then if somebody have the normal blood pressure, that person is having, that is considered normality. Now, if something above that, it become abnormal. If below that, not normal. How about this? Height. Somebody who is an adult, there are certain height we expect an adult to be. Nobody will be the same height. People cannot be the same height, but as an adult, there is a certain height we're supposed to expect to be. Above that height, you become a giant. Then below that, you become dwarf, they call it. But there's a certain level we consider normal. The same thing with income. Like if I tell you that there's a teacher in Maryland and her income is 200,000, that's not normal. I mean, to her, it will be normal to her, right? But generally speaking, I met a teacher, public school teacher in Maryland that is making 200,000 a year. That's not normal at least for Maryland income scale for teachers. It's usually between 55,000 a year to 75,000 a year. Am I right?
Yes, but Professor, continue. Can you just clarify continuous again? It just means that all of the data points are included, not just whole numbers, right?
Yeah, continuous means that it's measured, cannot be counted.
Okay.
Continuous variable, yeah, continuous variable. So now, if I ask you to tell you that there's a teacher in Maryland and her annual income is 20,000 a year, that's not normal for a teacher, public school teacher. It's not normal. So there are certain variables that we consider normal, and we model those variables using normal distribution. So the distributions of this type are known as normal distribution, or you can call them bell-shaped distribution, or you can call them Gaussian distribution. You know, Gaussian name, that name came from the mathematician that derived it. His name is actually Carl Friedrich Gauss. Anyway, so this leads us to this short definition, which says, 1 minute, that's just 1 minute. We say that the normal distribution is a continuous, symmetric, bell-shaped distribution of a variable. So, we use normal distribution can be used to describe any variables. I have already mentioned them because the deviation from that normal level is very small. You can see the chart right here. We call it the bell curve or the symmetric curve. You can see symmetric, like a bell. You can see the symmetric sides. You can literally fold this side to that side, you know. And it is asymptotic, and I mean, everything is can see from picture here. Example, you have the normal range of systolic blood pressure is between 110 to 140 millimeter of mercury. So if it's 145, not really normal. Or if it is 100 for systolic, not normal. So this is the rate. If it is 115, 139, you know, normal. How about this? The normal interval for a person's triglycerides is from 30 milligram per deciliter to 200 milligram per deciliter. See, that's the normal range. Above that, not good, not normal. Below that, not normal. Now, how about the birth weight for a baby? 6 to 9 pounds. More than 9 pounds, we say that baby is overweight. Am I right? I mean, bigger than 9 pounds, we say that baby is overweight. If it's less than 6 pounds, that means underweight. So that will give you an idea what I was talking about normality in statistics. Now let's look at the properties of the normal distribution. First is that the normal distribution curve is bell-shaped, shaped like a bell. You can see right here. See? Shaped like a bell. Second one is this. The mean, median, and mode are equal and are located at the center of the distribution. You can see right here. See the line. This line represents the mean, median, and mode, and they are equal and they are located at the center of this distribution. You have the normal distribution is unimodal. That means it has one mode. You can see that it's only one peak here. Only one peak. That's one mode. The curve is symmetric about the mean. Yep. For example, you can see that, like I explained a few minutes ago, you can literally fold this side into that side. You know, it's the same on both sides. Then the curve is continuous. That is, there is no gap. Yes. See, it is continuous. No gap. It just can be measured, cannot be counted. And it continued. It can never touch this line, even though it keeps getting closer and closer to it. So we say that the curve never touches the x-axis. Yes. Then the total area under the curve is 1 or 100%. That means this side is 0.5 and this side is 0.5. So the total area becomes 0.5 then plus 0.5 equals 1. Why am I using four figures? Because in the table that I will be using, all the numbers there are in 4 figures. Okay? You can see the total area is 1, which is all 100%.
So why are you, say it again, why are you using 4 numbers instead of 0.5?
Yeah, it's the table we'll be using for this. Let me show you the table for normal distribution. Let's see. Okay, it's gonna be here. And then binomial. Okay. This is binomial. Let me okay, you can see the table now, right? But the one we'll be using is normal, this one here. So we're using this one as it's normal. See, they're all 4 digits. 1, 2, 3, 4. Otherwise, if you write 0.5, you're still good. Nothing wrong with using 0.5. Now let us see how to find the area under the curve. Now, to find the area under the standard normal curve, 3 things you need to do. First, draw the curve. Second, then look for the go to the procedure chart and follow the instruction from there. This is the procedure chart right here. I'm gonna open it so you can see it. This is the procedure chart. Okay. See? So with the curve, if you draw the curve the right way, it must look like one of these here. And then you follow the direction from there. And then answer. Then next, the third thing is to write the answer. Okay. So let's do this. The first question, the very first question says, find the area under the normal curve, under the standard normal curve, which lies to the left of Z 1.76. Z 1.76. That's part A. So the first thing is to draw the curve, draw the chart. Okay. So 1.76. Remember, 0 is going to be here. Then 1.76 is positive. So it's going to be on the right side. So you can draw the chart. Okay. Let's draw it. Then, of course, we can now go from here. Okay. All right. So I'm going to make some adjustment, just a little adjustment. I'm going to put the center line. Put the center line. Should go from here. Let's start to represent the mean, median, and mode. Then I'm going to put the line that represents 1.76. Oops, excuse me. I'm going to undo this. Okay, let me put the line that represents that. This line represents 1.76. Then you gotta shed it. Shed it. Okay. So I'm gonna make sure that I have the out. Oops, excuse me, sorry, a mistake. McKenny, who's coming in?
Professor, why is 0 in the middle?
Give me 1 minute. Let me undo this. What was the question again?
Why is the 0 in the middle?
The 0 represents.
Why is 0 the middle value?
You know, in the number line, you have 0. You have on the left side is negative, on the right side positive. Am I right?
Yes.
Yeah. So this one is 0 that separates the negative side from the positive side. So from here, you start from 1, 2, 3, you know, then from here, you go from -1, -2, -3. You know that from your algebra class. Remember, and not only that.
Is it always going to be like this in a normal distribution where the center line is 0?
Yes, that's what I'm about to explain now. So from the algebra class, left side is negative, right side is positive, in the center is 0, right? Am I right?
Okay.
Then,
yes,
for the standard normal distribution, the mean is 0, and the standard deviation is 1. And remember that our mean is at the center here, so it's still 0. So 2 reasons for that. Okay? One is that it represents the demarcation between the negative side and the positive side. The second reason is that for the standard normal distribution, the mean is 0 anyway. So we'll come to that in a few minutes. So in meanwhile, let us draw the share the space that represents this. I'm gonna share it. All these spaces present. I'm trying to make it easy to shed. maybe I'll try I'll try using a single lines to shed it. You know. See this area was shaded, right? So it says, oh, I think I shaded the wrong side. It says to the left of Z1.76. This is 1.76. The left is this side, right? So I'm gonna shed this side. So let me use single line to shed it. That will be more clear to you. So I'm gonna shed to the left of it. Okay, share the left. Okay. All right. The sharing part is more challenging because you gotta trace all the enclosed. All right. The next one is this. Okay. See, because this is the left of 1.7. This is 1.76. This line represents 1.76. This shaded part represents the left of, because to the left of that. So the area I'm looking for now becomes area equals, now let's go to the procedure table. The procedure table, I'm gonna use this to represent it. So what diagram here look exactly like the one I shaded? Remember that the one I shaded is this one here. You can see, right? See the part I shaded, right? Now, tell me what diagram here look exactly like that.
The second to last one.
Yes, does this mean this one here?
Yes.
Yes, exactly. And what did it say? It says, look up the Z value to get the area at 0.5. See that? So that means we go to the we go to the table to look for the area, and the table is right here. Somebody's coming in. So I'm gonna put the table, and they say add 0.5 to it. The one minute, near who again? Okay. I make all. Okay. So let's find let us find 1.7. So you gotta look 1.7 under 6. So you gotta be you can see a Z right here. So here you get for 1.7, but you gotta go under 6. So 1.7 under 6. You follow that line. 1.7, you go under 6 right here. See 6 right there. 0.4, you can see 1.7. Like about 0.4608. 0.4608. 0.4608. 0.4608, and it says to add 0.5. 0.5, that, and then that give us 0.9608, or if you like, you can call it 96.08%. So, any question onto that? So I want to say this.
Yes. Why is 96%? What? The area to the left of 1.76 is 96% of the distribution? That doesn't look right.
Instead from here, see 0.9608.
But it doesn't comprise 96% of the total distribution.
If you multiply by 100, if you change it, if this is a decimal, if you change the decimal to percent, that's what it is, 96.08.
96% of what?
Of the entire curve. Yep.
Lies to the left.
Yes,
The
to the
part that
left,
you
right here.
want.
See the shaded part. The shaded part.
That part. Okay.
Now,
Okay.
I want to say this though. I recommend that you use for normal distribution, we have 3 different type of tables. Use this one we are using here. You'll be fine. The one they show you in your homework is different. That one is a cumulative type. So if you are using that one will be a different set of rules. So if you know the rules, you can use that, fine. You get the same answer. But to avoid confusion, don't use the procedure table we are using here for that one, the one I give you in class. I mean, the one they give you in the homework. That is why I said, print this one, keep it handy so that you can use it for your homework. The one they have in the homework that they give you is cumulative. They have a different type of rules for that. Okay. All right, let's look at the second one. It says to the right of Z 1.76. This one, I'm using this same number, but this time to the right of it. That's part B. Part B says to the right of Z 1.76. So we're gonna draw it. Solution. Okay. To the right of Z 0.76. Again, we draw a chart. Okay, we have our 0, 1.76. Okay. Now we can put our line.
Can't you just do 1 minus 0.9608?
What's that again?
Can you just do 1 minus 0.9608?
Are you talking about? Hold on.
Yeah.
Are you talking about this one here?
Yeah, to get the area to the right, can't you just subtract the area to the left
Well,
from 1?
We'll come to that. Remember, it's step by step. Let's take this one first. So that we have okay, now we'll make our chart. Make sure you're seeing this. So we go here. Oh, excuse me. And here. All right. All right. So I'm going to adjust this a little bit. Okay, good. Then I'll put the center line. Put the center line, which is right here. I'm going to put the line that represents 1.76. Then I'm going to shed it. Okay. All right. But I said this time you say to the right of it. So I'm shedding the right of it. Now for you, if you are drawing this, you can use your pencil to shed it. It will be easy for you. You can just use your pencil to shed the required parts. You know. All right. So this is the right of 1.76. When it appears like this, we say that it is at the tail. Call it tail. Tail. And then it's gonna be, you see when I say tail, I mean this side, this shaded part is called the tail. So the area. Now, we have made the drawing. Now let us go to the chart, procedure chart. The procedure chart is right here. So I'm gonna put it for you. What diagram here looks like the one I have? Which one of them?
The second one.
Yep, you can see. And it says that place, it says that in any tail, look up the Z value to get the area, subtract the area from 0.5. See? You find the area from the table, you subtract it from 0.5. Now, remember, don't forget, this is for this table, not for the one that's in your homework. So let's find the area. So that means we're gonna get 0.5 first. 0.5 minus. Now we look for the area for we look for 1.76 on the table. 1.76 on the table. So we're gonna go to the table and look for 1.76. We have it 1.7 here, but you gotta go under 6. So you got 1.7. You go under 6. See? It's under 6 right here. We have it before. I just want to make sure that you get used to this. 0.4608. 0.4608. 0.4608. That'll give us the answer. So I'm going to write this down so we can get it for the calculator. So I got 0.5 minus 0.4608. So our calculator we can help us with that. Where's my decimals? Right here. 0.500 minus 0.4608. 0.0392. So we can go and type it in. 0.0392. Or if you like, I can call it 3.92%. Okay. Yep. So that's basically how to use it, the table. You draw the chart, make sure you draw the correct chart. You go to the procedure chart, follow the direction from there, and you get the answer. Now let's do part C. Any question before I do part C? Any question on this one? Okay, good. Part C says between Z negative 0.87 and Z 1.28. Okay, that is part C. C, the solution between Z negative 0.87 and Z 1.28. Now we can make the chart. One side is negative, which is negative 0.787. 0.87. And then, of course, you know, after negative, you find 0. The next will be 1.28. Now I can put your chart. Okay. Your chart can be, you start putting your drawing. I got the horizontal axis. Then, of course, the okay, we have them here. So I'm gonna move this back a little bit. Oops, excuse me, 1.28. They're gonna put the center line. The center line is right here. Okay, I'm gonna undo this. Center line should be the center. Okay. Right. You can see it very clearly. Now, one side is the right side. It has this. And for left side, it's gonna be right here because it's negative. So you gotta be right here, negative. And negative 1 point. This is smaller than the. This is smaller than 1.28. So you're gonna be 1.28 is right here. Now you can say between them, say between these two, between negative 0.87 and 1.2. So you got a shared between them. So you got a shared here. So you got sharing will be in between them. Okay. All right. Okay. And little by little, you can finish sharing them. Now, the last one here. Okay, see between them. So that the area now becomes, now you go to your procedure charts and see what they have there for us. Now, which diagram looks like what I have here? You can see what I have.
Number 4.
So you say number 4?
Yeah.
That's number 4, right? And you can see what it says there. It says, look at the zebra to get the area, add the areas. So you find the area from the table and you add them. So let's find the negative 0.87 from the table. So I'm gonna find this from the table. Now, if you're using this table, you don't need to worry about negative sign. Negative sign tells you that it's on the left side. That's all. Now, the table they use for their homework is different, have a different rule for that. Anyway, in any case, what we are looking for here is for the first one is negative 0.87. So that means since the negative only tells you that it's on the left side, just look for 0.87 here. This is 0.8 right here. See 0.8, but you gotta go under 7. See, under 7. 0.8 gonna be under 7. Okay, under 0.3078. Okay, 0.3078. Plus, because that is to add them. Now, next is to find 1.28. Let's find 1.28. See, 1.2, gonna go under 8. Under 8. See, 8 right there. And 1.2. 0.3997. 0.3997. So now we add it together, our answer. Let me write them down. 0.3078 plus 0.3997. So let's get this from the calculator. Okay, 0.3078 plus 0.3997. 0.7075. So 0.7075. 0.7075. See? So just double checking this. 0.87. 0.8 under 7. 0.8. Go under 7. Okay. Yep, we got everything correct. Now, that is how we do it. Now, any question? Miss Elliot, what was the one you're asking me before?
I don't remember it. I think I'm good for now.
Okay, good. Okay. Now there's another way of doing this. I mean, there's another way of asking you the question. This is, in this case, they ask you the question as if they are area. Area is another way of asking you to find the the required probability. Okay. So sometimes they ask you with that way. Sometimes they ask you as with symbol this way. You can say find the probabilities for each using the standard normal distribution. It is the same thing I'm asking you to find the area. For example, this one here says find the area, find the probability for this one, P. So let's try two of them. Okay. So A part solution. So it's just the same thing, just that they ask you as with symbols. This time around, why is it the same thing? It's a find P of this. That means find the area between 0 and 1.45. That's what it means. So the same thing, you make your chart 0, excuse me, 0 here, 1.45. And then of course you draw your chart. Okay. Right here. Then put the bell curve. Okay, put the center line. And it says between 0 and 1.45. This is 1.45 right here. So we're gonna put 1.45. The line that represents 1.45 is right there. And it says between 0 and that. Between 0 and that. Okay. You're showing me something, Miss Elliot. What was that? Is it for this one? We'll find out. So you gotta share the part between 0 and 1.4. So you gotta share it right like here. Share this. Okay. All right. Make sure that you share the actual portion that is between the two. Okay. All right. Okay. All right. Okay. Mini novels. All right. I hear. Is that what you got, Miss Arias? So because you said between 0 and that. So that means the answer now becomes we go to the procedure table, procedure chart. So let's pick the chart that looks like what I have. Which of them looks like what I have? This is what I have. Let me show you what I have again.
Number one.
Number one. Right? Yeah, because say between 0 and that, right? That's number one. Correct. Number one tells us what is that. Because this is between 0 and that. And it says, look up the z-value in the table to get the area. That's it. Look up the z-value to get the area. So for that, we just go to our table and look up the z-value to get this area. Look from the under 1.45. Okay, under 1.45. We can find the area from there. 1.45. You can see 1.4 is right here. You're gonna go under 5. This is 5 right there. 5. Then follow it to the left. You can see 1.45. 0.4265. 0.4265. Okay. 0.4265. And that's it. Now, Okay, as you can see, this method is just the same method that we did before. So now we are going to solve only one question here. Choose one from this screen that you want me to solve. Choose one. Let's solve that one, and then we move to the next thing.
Okay, let's do D.
D. D. Okay, D. D is almost okay. It's almost like this one.
Oh yeah, no, do the one that says greater than Z. Okay, yeah, so do probability
You mean this
of
one
the
here?
area over 1.65.
Are
Yeah.
you talking about part C? Or are you talking about
But
this
we already
one?
did that one too. Okay, B. Yeah, you didn't do B. Do B.
Do B?
Because we
Okay.
already did.
Okay, let me do B then. So I'm gonna do part B. So it says as part B. This is B. Oh, excuse me. B. Solution. Okay. Actually, I should bring it up then and go down. So Z to the left of that. Okay, so we have negative 1.65. Got 0. Anyway, now let's put this our chart in there. We put our chart in there. So have insert this. Okay, put diagram. And then the bell curve itself. Okay, now I'm gonna adjust this because yep. Then put the center line. Okay. All right. Now it says D. It says to the left. It says less than mean to the left. So I say less than, that means to the left of this. Again, this is in a tail. This is in a tail. So this is the left of it right here. This is the left of it. Okay, we have left of this. Okay, left. Okay, this is right here. All right. So shade it all. So now we can now go to our procedure chart to look for what we're gonna put there. What diagram looks like this one?
Two.
2, yeah, exactly. So she's in the left. So, and for 2, it says there that it says, look at the Z value to get the area, subtract the area from 0.5. So, now we can now write here 0.5 minus gonna be equals, okay, equals 0.5000 minus. Now let's go and look for negative 1.65. Now, remember, if you're using this table, you don't have to worry about negative sign. Negative sign is just to tell you that you're on the left side, that's all. So you just look for 1.65. So we look for only 1.65. And we look for that here. 1.65. 1.6 is right here. You can see Z 1.6. You gotta go under 5. 0.4, this is 5 right here. 1.6. 0.4505. 0.4505. 0.4505. So we subtract it. I'll write this down. 0.5000 minus 0.4505. So from the calculator, we can get that from the calculator. We have 0.5 okay, 0.000 minus 0.4505. That was 0.0495. 0.0495. 0.0495. So that's how you do it. When you get a chance, try the other examples here to get stronger on this. Now, let us do the opposite of this, because you can do the opposite of this, what we just did. This is how we do it here. For the opposite is finding specific specific z-value for a given area. That means doing the opposite. Look at this one here. It says find the z. This time around, they give us the area and they want us to find the z. Remember this one that we did, they gave us the z. See, they gave us the z's. See, even at the beginning, they gave us the z's. And they asked us also to find the area. But this one, we are doing the opposite. It said they give us the area and they say find the z. In this case, say find the z value such that the area under the normal distribution curve lies between 0 and z, between 0 and z. Okay, but it doesn't tell us whether it lies between 0 and z on the left side or on the right side, you know. But given that normal distribution is symmetric, we can just assume that it's on right side or left side. So let's suppose we use left side. I mean right side, we have this. We don't know the z. Z is what we are looking for. And it's between 0 and z. Okay. So I'm gonna put the line, it's between 0 and z, between 0 and z. So let's put the our line. Say between 0 and z. So now I'll make the bear curve. So between 0 and z, I'm gonna put the center line representing the mean, median, and mode. Okay. They say between 0 and z. Between 0 and z, I mean between 0 and this z right here. And they say that this is they gave us the area. They say that it is the area is 0.2123. That's what they gave us. So I'm just gonna share it first, then I'll show you the location of the area. So you can see. All right. Yeah. Gamble. Okay. Now, one more and then we finish. So this will tell us between 0 and z. And they say that z, the area is, which is the shaded portion, is 0.2123. That is the area they showed us there. They said that area, it says area is, this is the inside this place, this is 0.2123. So that means our area is 0.2123. And we're looking for z. Z will become equal to, now we go, remember this time we're doing the opposite, we're finding z. You go to the table and look for this number. If you don't see this number exactly, you use the number that is closest to it. Okay. So going to the charts, I'm gonna look for that number. 2123, I believe, right? I think it's 2123. Let me see it again. 0.2123, yes, 0.2123, 0.2123. So this time you're not looking for the side, you're looking inside the table. For 212, see, I'm lucky, I found this here, 2123. Now, if you don't find it exactly, choose the one that is closest to it. Now, if you follow it to the left, you'll see 0.5. Follow it up, 6. So it's 0.56. 0.56. 0.56. Now, they didn't tell us whether it's on left. See, this question didn't tell us whether it's on the left side or right side. So that means it can be either this or it can be, like if I draw this, depend on the diagram, if I put this chair on the left side, that means that our Z will be, what means that our Z will be equals negative 0.56. But they didn't tell us that. You just said, so I just assume that it's on the right side. You can either answer is correct, since they didn't tell us which side. But most questions tell you the direction. Any question before I show you another one? Okay, let's look at another one here then. Excellent. You say, find the Z value. Find the Z value to the left of the mean. See, it tells us the direction to the left of the mean, such that the area under the normal distribution curve between 0 and Z value, and the Z value is 0.3460. Again, solution. Solutions. Okay. Again, you need to.
Can you express that as a formula?
Huh?
Can you show that as a formula?
I'm trying to figure out what you mean by showing it as a formula.
Like, are there formulas for this type of question where it's like P of blank?
Not really. It doesn't follow a formula. Just follow the you have to you just say I was call it that steps. You follow some steps, not the formula. Yes.
Okay.
So just the steps that you write. You draw the chart first of all. Make sure you draw the correct chart, because
I'm talking about the previous thing where we had to find the area. They were expressing questions as a formula.
You mean in this class?
Yeah, like the last thing we were doing with area, with like the way it would say find the area, it would be like that.
This one here?
Blank. Yeah. No, you already passed it. Go back down.
I passed it.
Yes. Okay.
Oh, this one here?
Wait.
Like this one we added?
I don't know. Show the questions. Show the question. Show the question. It's not expressed as a formula. Go back down.
Go right down.
Back down. Okay, there. This. Okay, P
Okay,
parentheses blank.
Yeah, this one they just ask you to find it. Remember this one we are giving the Z, and they want us to find the probability. So that's why they write it in this form. But this one they just give you the area, and there's no symbols. I know what you mean. I think what you mean is symbols.
Yes, are we going to be asked this in the form of symbols?
Just the direction steps that you use. You write the Z equals, and then get the direction from the follow the direction, get it from the table, and that's it.
Okay. Okay.
So you have it says find the Z value to the left. To the left. That means on the left side. So that Z value is on the left side. That means you have Z right here. On the left side. You have 0, and then you can make your charts. Make the chart here. Then here up. Then okay. Then make your adjustments. Okay. I can move this a little bit. Now you can put the center line. I put the center line. Then put this. He said, find the z value to the left. So the area under the normal curve is between 0 and z is 0.3460. So find the z value to the left. This is the mean. This is the left on the mean. So you're going to share the left side. Okay. And then share this. All right, share that. Okay. And then share this. And this one. That's it. So so now say the area they gave you is area equal.
Wait.
Mhm,
Hold on.
mhm.
The question says to the left of the mean, not to the left of z.
Now this is the mean right here.
Right.
So this is
But
z
is that
value can be any side on the left on the mean.
right? But
See,
But I
it
thought
can
it would
here.
be like
it
directly
cannot be on the
next
mean.
to it.
It cannot be on the mean. It had to be on the left, any side that is on the left of the mean. You see what I mean? It cannot be
No.
on the mean.
oh, we're
can't it be
finding
on
the
the mean?
value.
Yeah. The z value to the left of the mean. So you can put it here, you can put it here, but so long as it does not touch the mean, we are good. And if it doesn't touch the mean and it's on the left side, that means all the left side, that means it's on the tail. Yeah?
So that's because it says Z minus.
Yeah, because
But
it said,
why are you
no. Because it said on the
area
left.
to the left of
It said to the
z
left.
instead
Oh.
of
I said, what do you
why
say?
are you
Uh-huh.
why didn't you color in the area between 0 and z?
No, but it didn't say between 0 and z. It said to the left. You cannot, if you say to the left, it cannot touch the 0. On the left of it.
To the left of the
Okay.
Z and not the mean.
Yeah. Find the z value to the left of the mean. So the z value can be anywhere to the left of the 0. So if it's from, I mean, even if you put it from here, that means you go from the left, from this side all the way to the left. That's why it's on the tail. Yeah.
We just have to make sure it doesn't touch the mean.
Yeah, it doesn't touch the mean, because it's set to the left of the z. You're looking for the z value itself is on the left side of the mean. Yep. Now, for this, can you see that it's on the tail? And remember when we were doing the other one, we add, right? So sorry, we subtracted based on what the procedure chart tells us. But now we are doing the opposite anyway. Let's go and do the area we say that is 0.3460. Now we go to the table to look for this area. Okay, 0.3460, 0.3460. I saw 3436. I saw 3461. That's the closest. I didn't see 3460. So I'm going to use the closest one, which is 3461. Of course, I cannot use 3438. That's too far away. I cannot use 3485. That is also too far away. The closest is 3461 because it's only 1 point away. So I'm going to follow you to the left, which is 1.0 and up to 1.02. 1.02, right? So that their z will be equals. Now, because it's on the left side, you gotta be negative. So now let's go to that table again. Make sure I got it correctly. Yep, see? 1.02. You gotta be negative 1.02. 1.02. Yep. Any question?
Yeah. Why doesn't it look like this? Wait.
Let me see. No. That one is between 0 and z. That one is between 0 and z. I mean between the
But that's
mean.
what it says the area between 0 and z is 0.3460.
No, you have to look at the direction first. You say find the z value to the. You see, I highlighted it for you to see. Find the z value to the left of the mean, such that the area under the normal curve between 0 and z value is 0.3460. Okay, I see the confusion. I see the confusion. Okay, probably maybe I should remove this. So the area under the normal curve is between so probably I should let me change this probably normal curve from the z value that make it that's clear the confusion, right?
Yes. Yes.
Okay. And the record from the z value is 0.34. So that's okay. That's let me save it that way. Okay, should I? Yeah. Same. So any other question?
Thank you.
Okay. All right, let's do the last one. Last one, and after that we'll be done for the day. And you go and enjoy your spring break. She says, find the z value to the left. See? To the left of the mean.
Did you have to say it like that, Professor?
Huh?
To the left. Did you have to put emphasis on the to the left?
You want, if you want, I can make it to the right. Either way, it's still the same thing. Yeah, so I wanted to show you this one because this one is unique. It says such that 98.87%, they use percent on this one. So 98.87% of the area on the curve lies to the right of it. So again, you make your diagram. You have your 0, and then it's a z value to the left. So the z should be on the left side. Z. So you can put your okay. You can put your chart first. Let me put the chart first. Now we have the horizontal axis. Okay. Then we have this one here. Oh, excuse me. Maybe I'm too close. It's too small. Okay, I'm gonna adjust this. I don't know. All right, let me make some adjustments. Oh, excuse me. Center line. Put the center line. Then the z value we're looking for, I'm gonna put the line that represents it. Such that, see, you say find the z value to the left. So that 98.8%, 98.87% of the curve lies to the right of it. So we're going to have unbelievable. I have this here. So you're supposed to go this way. 98.87%. That's the area they give us. Lies to the right of it. But the z value is on the left. But 98.87% lies to the right of it. So you're gonna look like this. This chart is gonna look like this. Okay. But the z value is on the left. Okay. Okay.
What you touching the mean?
Yeah, he said the z value is on the left of the mean.
Hold up now. Now I'm with Elliot. Hold on now.
We don't see the highlighted part of it. It says z value to the left.
To the left of the mean.
I'm gonna show you something that you didn't see. Give me 1 minute. All
right. Be
1
quiet.
minute. There's a part of it that of the portion that you must not have seen. Okay, and one more, and then I'll close that. Okay, good. Now he said, find the z value to the left of the mean, such that 98.87% of the area under the normal curve lies. Maybe I didn't get this right, so let me see. Give me 1 minute. I got no color. No color. So such that 98.87% of the area of the distribution of the curve lies to the right of it. That's the part you didn't see. Z value to the left, such that 98.87% lies to the right. See, right to the right. But what I'm interested in is the Z value, which is on the left side. So the area they gave you equals 98. Mr. Dwayne, did that answer your question?
So the reason why we crossing the mean is because of the last part of the question.
Yes.
The curve lies on the right.
Yes.
Curve lies to the right of it.
But the Z value they said is on the left side. Okay, 98.87%. When you change this to zero to our decimal, you're gonna be equals 0.9887. See?
Right.
Now, but we cannot see this on the table. 0.9887. If you look at the table, they stop at 0.4999. Am I right? Now, what do we do? If you remember from the charts, when we're drawing the charts, the one that looks like this in the procedure chart, normally when you look like that, we add 0.5. Am I right? That's what it says. Add 0.5 when it looks like that. Am I right? Say to the right of any Z value, look at the Z value to get the area, add 0.5. That's what we But now, since we are doing the opposite, oh, excuse me, I didn't show you the diagram. Okay, sorry about that. It's right here. When you look like that, see, say add 0.5. Yeah. Now, but since we are doing the opposite of that this time around, we're going to subtract so that the Z will now become so that the area we'll be looking for will now become 0.5. This minus
0.4887.
Yep, that's gonna be 0.4887, right? Right? So that the Z value now becomes equals negative because it's on the left side. Instead of looking for this, we're gonna be looking for 0.4887. So we go down there and look for 0.4887. Okay. So I'm gonna put the here 0.4887. Okay. Right here. Found it. Yeah, follow to the left. 2.28. See? 2.2. If you follow to the left, you're gonna get 2.2. Okay. 8. So answer will be 2.28. Negative 2.28 because it's on the left side. So that's how we do it. Question on this before we now round up because we are done, basically.
Pretty easy.
It's easy, right?
Pretty fast, yeah.
Very good. Mr. Gambo, what do you think?
I'll watch again.
You always say that. Are you sure you're watching this all this time, Mr. Gambo?
A proportion, Professor, because sometimes I get lost. That's when I turn my camera. When I get going la land. But then rather ask a bunch of questions, I'd rather just wait it out. And then like towards the end, the more you did, it started making sense. So yeah. I got to go back to watch the beginning. So I normally don't start really grasping it till almost the end of class, and then I'm like, God, it makes the beginning of the class make sense. So then when I watch the video, I'm like, okay. Yeah.
Okay, I hope so.
Hopefully my grades is showing it. Good Lord.
I hope so. Anyway, Miss Elliott, you have no question, Miss Elliott, for me?
What are you showing us now?
Oh, that was where we will continue after the spring break.
Okay.
Standard amount.
Miss Elliott about to be my study buddy.
Who?
Hit me up. I almost have an A in this class. I started out with a C, and I'm up to a B, and I'm gonna get up to that A. So
Where are you now? Where are you now?
I have 89% in your class, which is
Oh, that's good. That's great. That is great.
Look, I just got back to a C. That was because of last week.
I'm working hard. But you know what? It really does help to have someone to study with, because I've asked people to study with me a few times. I asked my mom, and she was like, I don't really know what you're talking about. And I was like, it just helps me to say the stuff out loud, honestly. Like, you know, just have someone who let you talk through it.
Yeah.
You know?
Oh.
Yeah, it makes sense. Yeah.
Okay. So anybody in the class, anybody have question for me before we end?
I have a question, but it's about my attendance grade. I don't know if you want to wait until everyone leaves or.
Okay. All right then.
Wait, Professor, I have a question real quick.
Go ahead.
I'm sorry. So you said for the spring break, all we have to do is this homework that's due, this classwork, this homework that's due tonight, right? Not tonight, but this weekend.
Yeah, the homework is available, but it is due after the spring break. So we have not even finished it. So the homework is just for you to keep practicing. The only thing that is due is this classwork that I will put after as soon as we finish the class. That is due tomorrow.
Okay.
Other than that, other ones are not due. They are due after the spring break. So you still have
but the homework is due on the 25th. That's why.
Oh no.
The 24th. I meant the 24th.
No, not that. No, not. Maybe you are talking about it different. Let me show you. Give me one. Let me show you. You can see. You can look at the model. Can you see the screen? Yeah.
Yeah, I can see your screen.
See, this is the homework. It's due on April 7th. Homework 6.
Oh, okay. Are you changing the date? Because at first it was telling me something else.
Yeah, I changed it to April.
You did? Okay, that's why.
Because when I discovered that we have a spring break, I changed it. And when we come the week of spring break, we finish this topic, so you can down put the homework. The one that you
thank you, Professor.
It's only the classwork 9. Yeah.
Thank you. You have a good one, guys.
You too. Have a
nice. Thank you.
All right. Good night.
Enjoy.
All right, good night. Yeah. Class over. So who else have a question for me?
I did. My attendance grade is a 67, and I have not missed a class.
What's her name?
Phyllis Roberts.
Let me see. Yeah, attendance. Because I have not updated grades. Attendance grade for a while. Miss Roberts. Okay. So everything goes by what I have on the attendance book. I see have some of the papers. Let me get the papers.
Okay.
Okay. So what I have here, Roberts. Yeah, on the 1st of March, I didn't see you on the 1st of March, and then on the 8th of March, I didn't see you on the 8th of March either.
I have not missed any classes.
Yeah. Then also, this is for the first one. This one is for.
I mean, my computer may have died and I came back in, but I've been in every class though.
Then this one is for the these two. Let me see if I can find another one. I have this. This is the because this one of these have 4 class sessions. That means like this one have 4. This one here have our first class, second class. 1 to 4 weeks. This one is 4 weeks. That's 8 weeks. The one we have now. Oh, there's another one here, which is the 9th week here, Roberts, and also on the 22nd. 16th of February, I didn't see you either. So I go by what I have on the paper here, all these papers. So I mean, that's what I can say. Otherwise, if you watch because I always post the videos. And during that time, anybody comes in, it will show on the video that this person, and then I'll click and accept the person. So if you can watch those videos and see your name there, you can let me know. But what I do is what I have on these papers.
What days are you saying?
First one is on. I have this one on the robustness. It's on the 16th of February. I didn't see you. Then 1st of March and 8th of March. I didn't see you.
You saying I missed 3 classes? I missed no classes, and you have 3 classes I missed?
That's what I'm seeing from these papers. As
Oh
people come in, I check the person in, and yep, that's what I have here. Is there any way you can show me the proof that you are in the class on those days?
I don't know if I can pull up Zoom history or something. I have to think about that, but I have not missed any classes.
I mean, you can write the days down, and if you can figure out a way to show me that you are here that day, then I will.
What way is acceptable to you? Because that's what I need to know.
I don't know how you can, because only the video. I mean, if I watch the videos that I put on those days, because if somebody comes in, it pops out, it shows on the screen, I accept the person. So if it's you shown on that day, I mean,
you said the 15th. I'm sorry, you said the 15th.
Let me start from the first one is the 16th of February.
2/16. Okay, what's the other one?
The other one is First of March and 8th of March.
3/1 and 3/8. All right, I will watch the video and send you pictures
on those
of
days. Yeah, see if your name it pops up.
3/1 and 3/8.
Mm-hmm.
Okay, thank you.
You're welcome. Now who else? Mr. Dwayne, you have a question for me?
Yeah. Cause this is gonna help my grade go up. I don't have a grade for this is just one. I think it's homework 3.
Homework 3?
Yeah.
Homework or classwork?
This one says homework 3, data description.
You have the grade for that?
No.
You sure?
That's what it said on my end.
Homework 3 doing. I mean, remember that homework is different from classwork.
Right.
Homework 3.
Mm-hmm. Lord, Professor, you let the people see how bad I'm doing in class.
Oh, come on. You asked me for this question. I'm answering your question. What do you mean? Homework 3 is not really here.
Yeah. See, on my end, and on my end, it says it won't even, it's weird how it's showing up on my end. On my end, it won't even let me, sometimes I can see your,
let me go this way.
I can't even see your comments on it or anything, which is weird. That normally doesn't happen. That's the only work assignment that's doing that.
Homework 3.
Yep.
French. Let me write this down. See what is going on there.
You might as well just give me 100 on it because you missed it.
I'm gonna go to Alex and get it for you. Gambo. Dwayne. Homework 3. Yeah, I'm gonna get it and get it. Are you sure you did the homework 3?
Mm-hmm.
Okay, I'm gonna check it.
And as a matter of, let me just check my
Alex, let me see.
Let me check my files right quick. What's this? This one, I forgot. What's the name of this class? I know statistics, but
Reports.
here we go. Math 107. Classwork, Excel.
All right.
So-
Gamble.
It won't let me see what I submitted on my end.
Looking for. I'm trying to find it.
Oh, homework is on the was that there?
Yeah, well, I'm trying to figure out. See, the Gamble homework 3, right?
It's on Alex.
See that right here. Can you see that? I didn't see. You didn't do any. You didn't do it right here. See? Can you see my screen, Mr. Alex? Mr. Gamble.
No, I didn't do it.
That's you right here, right? Huh?
Yeah. Hold on. Let me go
So
back.
this homework 3 is 0. You didn't do it. So, but like I said, keep your attendance good. Remember, we had a day, right? So you can still go back and after when April
I'm
last.
trying to see. That's
Huh?
weird. How did I miss that?
You're asking me. I don't know. Mr. Bram, let me ask you this: Have you been partying around or what?
No, I'll be at the church house.
You be at the church house?
Yeah. I be telling them I can't stay because I got class. The pastor don't be listening sometimes.
Now, Mr. Dwayne, you know what you're gonna do? Write it down so you don't forget. Write it down so that last week of April you can now know that this is the one you are missing, and so you can.
See, then that's gonna mess me up because you gonna let us. You said we only get to pick one.
Oh no, not one, not one. You're gonna pick up to 5 of them.
Okay, good.
Up to 5 of them. So not only one.
The crazy thing is the ones I know I'm gonna need is the hard ones. Those are the homeworks that you be having them long problems on. That's why I don't be finished. They so long.
It's college, Mr. Dewan. It's college. You gotta work.
I hope I ain't got no statistics when I get to Morgan State because they gonna be sadly mistaken.
I'm there too. I teach there too. And guess what? You know what I teach there? Business
What's
statistics.
that?
So if your major is business, you're still gonna see me again.
Yeah, Lord have mercy. Well, at least I know you're gonna record the class. All right.
All right.
All right, Professor. Thank you for letting the whole class know I ain't do my homework that day.
You asked me and answered.
All right. Good night, class.
Good night. Now, who else want to have a question for me? The rest you can go if you don't have a question.
Professor.
Yes, ma'am. Hello. Go ahead.
Oh,
Professor.
Professor.
Yes, ma'am.
Professor.
Yes, ma'am.
So I just went to the first day and I'm actually on video. Like my face is actually in the video that day.
Very good. Can you just if you can take a screenshot of that and email it to me, I will just
now. Let me tell you, I don't trust that because I've emailed you many times and you never respond to my emails. So I want to show you this here right now.
How are you gonna do that?
I look a mess. But I am at the very bottom.
I can't see that. I'm not seeing that, Miss Phyllis.
I'm right under Miss Elliott. I'm right there on camera.
Yeah, but I can't see this, what you say on your phone. Can you just do it now? Email it to me right now so that I will take care of it
email it to you
at the end of the class. I'm not seeing what is on your phone. If you can email it to me, and then at the end of the class, I will look at
email
it.
Email it to Canvas?
No.
You don't respond to my Canvas email.
To my email. Send it to my email. My email is on my syllabus. Can I see the email on my syllabus?
No. Okay. The email is on your syllabus. Hold on.
Yeah. So take a screenshot of that and then email it to me. Mention that we discussed this. Don't forget to put your name, first name, last name. Then I will look at it and then take care of it.
Now, I went through the second date. Only people that popped up are people that asked questions.
One of these, one is enough for me.
Oh, okay, all right.
Yeah.
So
One
I'll send you the
screen-
screenshot to
Yeah.
the email that is on the syllabus.
Yeah.
Okay,
Yes.
all right, thank you.
You're welcome.
Appreciate it.
Who else? Okay, I think everybody's good now. All right, Dwayne, go and enjoy your spring break, and because I'm letting you go now.
I didn't start. I was just being nosy. I was starting working. That's all. I'm sorry. All right, good night.
Have a good night.